Okay, so we're still balancing chemical equations. And if you're still not getting it, it's okay. Let's do some more practice problems. So the next one that we're going to do is practice problem number 4. And we're going to break it down just like we did before into the individual elements. So on the reactant side, we have iron, hydrogen, and oxygen. And again, we're going to do it the same way on the product side, but we're going to put it in the same order that we put the reactants so that we can compare them more easily. So we have iron, hydrogen, and oxygen. So on the reactant side, we have one atom of iron because there's no subscript, 2 atoms of hydrogen, and 1 atom of oxygen because there's no subscript there either. On the product side, we have 3 atoms of iron, and then 4 atoms of oxygen, which make sure you skip down to the O. So we have 4 atoms of oxygen and 2 atoms of hydrogen. So we're going to start with balancing iron first because that's at the beginning. We're going to leave the hydrogen for last because first of all, it's balanced already. And second, hydrogen is over here by itself. So again, that makes it easier usually to balance. So iron, in order to balance these, we need to put a 3 in front of the iron on the reactant side. That means that we have 3 atoms of iron over here. So there's 3 atoms of iron now. So the irons are balanced and the hydrogens are balanced, but the oxygens are not. So we need to fix that. So since we have 4 atoms of oxygen on the product side and only 1 on the reactant side, we need to change the number of atoms of oxygen on the reactant side. To do that, we need to put a 4 in front of this water molecule right here. So there's a 4 in front of the water molecule, which gives us 4 atoms of oxygen. But again, that 4 applies to the entire water molecule. So it changes the number of hydrogen atoms as well. So because each molecule of water has 2 atoms of hydrogen, and there's 4 water molecules now, we have 8 atoms of hydrogen total because 4 times 2 is 8. So now we have the irons balanced and the oxygen's balanced, but we just threw the hydrogen out of balance. So we need to fix that. This is a pretty easy fix because we have hydrogen over here by itself. So what we need to do is make 8 hydrogen atoms on this side. And because the hydrogen molecule has 2 atoms of hydrogen, we're going to put a 4 in front of it. So 4 molecules with 2 atoms each gives us 8 atoms of hydrogen total. So now this entire equation is balanced. Let's go on to number 5 and talk about that one. So we have, on the reactant side, we have Sb, which is antimony, and oxygen. On the product side, we have the exact same thing, SbO. So we have 1 atom of antimony because there's no subscript there, and 2 atoms of oxygen. On the product side, we have 4 Sb and 6 O. So the first thing that we're going to do is balance the antimony, the Sb. So since there's 4 on the product side and only 1 on the reactant side, we need to put 4 in front of the reactants. So now we have 4 atoms of Sb on both sides. The oxygens are not balanced because we have 2 on the reactant side and 6 on the product side. So to make these balanced, since we have a molecule of oxygen which has 2 atoms each, we're going to put a 3 in front of that because we need 3 molecules with 2 atoms each to make 6 atoms of oxygen. So now those 2 are balanced. Let's practice one more on this video. We're going to do practice problem number 6 up here. So we have KCl, that's an L, not an I, remember. I's will always look kind of like that on these equations to make it easier. So we have KClO. So we have potassium, chlorine, oxygen. So we're going to do the same thing over here. Potassium, chlorine, oxygen. On the reactant side, again, there's no subscript for either potassium or chlorine, so there's 1 of each of those, and then there's 3 oxygens. On the product side, we have no subscript for K or Cl, so 1 of each of those, and 2 oxygens. So you'll notice with this one, the potassiums, the Ks, are already balanced, and so are the chlorines, the Cls. But Oxygen, we have 3 on the reactant side and 2 on the product side. This is going to be harder to balance because you can't just put one subscript in and make it work. You're going to have to use, or that's a coefficient, excuse me. So you have to use a coefficient on both the product side, or the reactant side, and the product side. So it's kind of like when you do fractions, you have to do the lowest common denominator. So what we're going to do here is we're going to put a 2 in front of the KCl, and that gives us 2 molecules of this whole atom, or 2 molecules of this compound. And in those 2 molecules, we will end up with 6 atoms of oxygen because each molecule has 3 oxygens. So that's 2 times 6 is, or 2 times 3 is 6. Then, but that also changes the potassium. It gives us 2 of those and 2 chlorines. We'll come back and deal with those later. Let's finish dealing with the oxygen first. So we have 6 oxygens on the reactant side and 2 on the product side. So to make that work, we're going to put a 3 in front of the O2. That means that we have 3 molecules of oxygen. Each of those molecules has 2 atoms of oxygen. So that is 6 oxygen atoms total on the reactant side, or on the product side. So now the oxygens are balanced, and we need to go back and fix the potassium and the chlorine. And this is a pretty easy fix because those 2 are together. So we just put a 2 in front of the KCl, and it gives us 2 atoms of chlorine and 2 atoms, or 2 atoms of potassium and 2 atoms of chlorine. So now this one is balanced. Again, if you think you have it now, go ahead and go on to the rest of them and practice. Make sure you get it. If you're not sure, continue watching the videos.